Hello, hi everyone, welcome back to the channel. So this is your Ramandeep Singh. I'm back with yet another Leetcode problem after so long pause because I was busy in some interviews and in some not so important work, but will be consistent from this video onwards. So let's read the problem statement. The problem name is Invert Binary Tree. So we're given the root of a binary tree, we need to invert the tree, and after we invert the tree, we'll return the root of this tree. So so let's first understand the binary tree. A binary tree is a special type of tree where for each node we have at most 2 child nodes, and inverting a binary tree means for each node switch its left child with the right child, and hence switching the left subtree with the right subtree. Like here in this example, we have this node, this tree rooted at node 4. After we have inverted the tree, the left child that was 2 becomes its right child, and the right child that was 7 becomes its left child. And this is true for all the nodes. We can see that for node number 2 we had 1 3, and now we have 3 1. For node number 7 we had 6 9, and now we have 9 6. So we have to make this inversion for each node of the tree. And finally, when we have made it, we'll return the root of the tree, right? So let's see how we can solve this problem. But first, let's understand the problem statement better, because understanding the problem statement in a better way will make our life a lot easier. So like understanding a problem statement gives the intuition to solve the problem. So here we have this tree 4 rooted at this node 4. So let's start from the very simple statement. We need to invert the tree, means switching the left child with the right child. So let's say switching the left child with the right child is simple. Just swap the left pointer with the right pointer. It's a constant time operation. So it will give me 4 7 2. Fine. A constant time operation. 6 9. Then for 2 we'll have 1 3. So we have made the swap. But this is not the final form. We can see that we also have to make the switches for each node, for the child nodes as well. Like here we can see that for 7 we had 6 9, and now we have 9 6 in the final form. That means we also have to switch these nodes as well, or these subtrees as well. So let's make it 4 7, then 2, then for 7 we'll have 9, then we'll have 6, then for 2 we'll have 3, then we'll have 6. It's not 6, it's 1, I think. Yeah, for 2 we have 3 1. Now, or 3 1, we had 1 3 1 3. Now we can see that we have made the switch for node number 4, and here we made the switch for node number 7, but we also have to make the switch for node number 2 as well. We have to invert the subtree of the node number 2 as well. So let's do it. 4 7 we'll have 9, then 6, then we'll have 2, and we'll have 3. It's not 3, yeah, it's 3, and then we'll have 1. Fine. So is it the final form? 4 7 2 9 6 3 1. Yes, 4 7 2 9 6 3 1. So that's what we have to do. 1 step, 2 step, 3 step. Can we do the same for these leaf nodes as well? No, because we can see that these are the leaf nodes and they do not have child nodes. We can't switch anything for them, right? So swapping the left and right pointer is a constant time operation, but doing it for all the nodes is not. So what we have to do is, we have to start from the root node, make the switch for its child nodes, then repeat the procedure for the left and right subtree. So let's create a function which do this job. Let's call the function to be invert, which takes in a node, right? It makes the switches or the swap the left pointer with the right pointer. So let's say left, then it with right. So we have made the swaps, switch the left pointer with the right pointer. Then we have to do the same for the right subtree and for the left subtree. So for the left subtree, we'll call the function invert, pass this root for the left subtree, that is left, call the same function for the right subtree, pass the root of the right subtree, that is right, and this will do the job. So we perform swap for this node, then we perform swap for this node, then for this node, and so on. So from 4 we move to 7, then from 7 we actually move to 6. We have skipped few steps in this procedure. Why? We'll see why. So from 4 we move to 7, then from 7 we'll move to 6, because that's what this function say. From any node move to its left child, right? So from 4 move to its left child, that is 7. Then from 7 move to its left child, that is 6. But we can see that for 6 we do not have any left child, so we have to return from there. So when I call this invert function for the left child of node number 6, I encounter a null pointer, means this node is null. Since this node is null, we can't switch its childs because this node do not have any child at the very first place. And in that case, what we'll do, so if this node is null, then we'll simply return back to the parent, right? And that will be the case for the left and right child of the leaf nodes. When we'll call the invert function for the left and right child of nodes like this, 6, 9, 1 and 3, we'll end up with this base case, right? And this is my base case, and that was my recurrence relationship. Fine. So this will do our job. This function is going to perform the inversion which I want. So I hope it was really easy thing. All we had to do is swap the left pointer with the right pointer, like I did here, swapped it, then do the same for the left child, do the same for the right child. That's all. This was a high level view. If you just think about a high level view, not going to the nitty gritty of how the recursion is working, you have to take care of two things, a recurrence relationship and the base case. Just think about, you simply swap the left and right child nodes, then do the same for the left child, do the same for the right child, and whenever we encounter a node which is null, we simply return from there. Fine, that's all. Not going to the very details of how recursion works. Although it is easy to understand how it is actually working, we start from node number 4, we make the switches, the tree structure is like this, and now we recursively call the same function for this node, and then the tree structure is like this. These nodes are swapped. Then we call the same function for node number 9, and we can see that for node number 9 we do not find any left and right child. Fine, so because they are null nodes. Then we call invert function for the left and right child of this node, where we are passing null pointers for them, and when we are passing null pointers we end up with this base case and we return right from there. So from here I return to node number 7, and then I'll call the same function for node number 6, and the procedure repeats for node number 6. We end up with the base cases. Now I move back to this node number 7. Now I have explored all the nodes of this subtree rooted at node number 7, and now I move back to node number 4. That means I am at this point. Now from here I recursively call the invert function for the right subtree, that is this node. Fine. So from this node I recursively call the function for the left node, which is 6. Then I can see that it do not have any left and right child, so I end up again with the base case, and from this node I move back to node number 2. From node number 2 I recursively call the invert function for the right child, and this and I again encounter with the base case, because this node has null nodes. It do not have any actual child nodes. So from this node I move back to the parent node, that is node number 2, and also I make the switches. So first, when I'm encountering with node number 2, I actually switch these nodes, switch node number 3 with node number 1. Fine, so I end up with this type of configuration. Then I move back to node number 4 and I finally get this tree, right? So this is a top down way to solve this problem. That is, first swap the child nodes, now move to the child nodes. Actually recursively call the same function for the child nodes, like here. First swap them, then move to them. Okay, we can also do it in a bottom up approach. That is, first recursively keep moving down, then first recursively keep moving down, and while moving back to the parent nodes, make the switches. In that case, all we'll do is simply write this swap function after these recursive calls. That is the second way to tackle the problem, although that is also a recursive way, but just a way of solving a problem, or way of approaching a problem. And this swap is a constant time operation, right? It just swaps the left pointer with the right pointer. So let's just jump to the code implementation part. So let's write this function invert, which basically inverts the left and right nodes, left and right childs. If the node is null, we'll return right from there. Otherwise, let's perform the swap. That is a constant time operation. So let's create a temporary variable and store one of the childs in this temporary variable, and into that child which we have stored into the temporary variable, assign another child, and to the another child assign the initial child which I stored in the temporary variable. So we know how we do this, and then recursively call this invert function for the left node and for the right node, right? And here in this invert tree function, call this invert function and then return the root right at the end of it. Let's run this code, and it is giving me wrong answer because I think I forgot to write something. If node is null, if it is some problem, return. Okay, I had to write right here. Okay, okay, so that got accepted. I hope you enjoyed this video, and if you like it, then hit the like button, and stay tuned with me. I'll be coming up with new playlists and soon in my next video. Till then, take care. Bye bye.